Hi everyone, myself Suvashankar Reddy. Now I explain determine y admittance parameters with the condition, symmetry and reciprocity. Determine y admittance parameter with the condition, symmetry and reciprocity. Introduction. Determining y admittance parameters with the condition of symmetry and reciprocity is external in analyzing electrical networks. Symmetry enables that the network behave the same regardless of how it is oriented, while reciprocity means that the network's behavior remains the same when the input and output ports are interchanged. These parameters are critical for designing efficient and reliable electrical systems. Y admittance parameters. Admittance parameters are used to describe the behavior of linear electrical networks in terms of admittance. The consists of the Y11, Y12, Y21 and Y22 parameters which relate the currents and voltage at the input and output ports of the network. These parameters can be determined experimentally or calculated using network analysis techniques. Symmetry condition. The symmetry condition is Y admittance parameters implies that Y12 is equal to Y21. This condition ensures that the network's behavior remains constant, regardless of the directions of signal flow. Symmetry simplifies the analysis of the network and allows for easier parameter determination. Reciprocity condition. The reciprocity condition in Y admittance parameter states that Y12 is equal to Y21. This condition means that the network's response is the same when the input and output ports are swapped. Reciprocity is a fundamental property of linear networks and play a critical role in signal transmission and processing. Determining Y admittance parameter. To determine Y admittance parameters with symmetry and reciprocity conditions, measurements or calculations must be performed. Experimental methods involve applying no current or voltage to the network and measuring the resulting currents or voltage at the ports. Network analysis technique such as nodal analysis or mesh analysis can be used to derive the Y parameters mathematically. Applications of symmetry and reciprocity. The symmetry and reciprocity conditions in Y admittance parameters are external for designing balanced and efficient communication system. These conditions ensure that signals are transmitted reliably and accurately through the network. Symmetry and reciprocity also play a critical role in signal processing and RF circuit analysis. Examples: symmetric two-port network. Consider a symmetric two-port network with Y11 equals to Y22 equals to 2 ms and Y12 equals to Y21 equals to 1 ms. The network satisfies both the symmetry and reciprocity condition. By to these conditions, the network's behavior remains consistent and predictable. Challenges and limitations. While symmetry and reciprocity conditions simplify the analysis of Y admittance parameters, real-world networks may not always exhibit these ideal properties. In property factors such as compounds, environmental conditions, and non-linear behavior can introduce deviation from perfect symmetry and reciprocity. Engineers must account for this challenge when designing and analyzing complex electrical systems. Future research and developments. Ongoing research is focused on developing advantaged techniques for characterizing and optimizing admittance parameters in non-ideal networks. Machine learning algorithms, numerical simulations, and advanced measurements technologies are being exported to improve the accuracy and efficiency of parameter determinants. Future advancements in this field will enhance the performance and reliability of modern electrical systems. Conclusion. Determining why admittance parameters with the conditions of symmetry and reciprocity is critical for analyzing and designing electrical networks. Systemetry ensures consistent behavior regardless of orientation, while reciprocity maintains the same response when both are interchanged. By these conditions, engineers can create efficient and reliable systems that meet the demands of modern technology. Thank you.